Okay, how's that different than a flow?
Yeah. We have different types of 5-axis methods here, so we could do a between two curve. We can do a, we have different ways how we can program these in here. So, for example, I could say select these two curves. I can pick these two here, and I can choose to pick the surface. And with the same tool selected, I can use what is called, between two curve machining. So you can see now the toolpath is flowing between these two curves. I'm going to run a simulation just a part on it.
So those two curves were a way of kind of restraining the tool pathing?
It's basically flowing morphing between the two curves, following the toolpath being normal to the surface.
Okay. So in this sense, this is both concave and convex, the surface. I'm a little new to the 5-axis stuff. You would be restricted to a ball end mill in this case. You couldn't use a flat end mill.
We could use a flat end mill too. So I'm just using a ball mill for the purpose of demonstration, but I can swap it to a flat end mill. So here you notice that there's an unwind.
Right. So my question is, with the flat end mill, as it's traversing what would be a negative curve, like the inside of a bowl, which is along the tool path right now, it's knowing that the center point of the flat end mill has to be off the actual mold line, and it's using the actual square corner of that diameter to actually remove material to the correct size?
Yes, sir.
Am I? Okay.
Yeah, so let's go back and swap the tool out here. So I'm going to pause this for a moment. So you can see the contact point, the tool tip is on the surface, right?
Right.
Now let's go back and I'll stop this, switch back. I'll make a copy of this operation in here. And I'll go ahead and swap this out with a 3/4 inch flat bit. Just grab this flat bit, drag and drop the operation on it.
Oh, wow, you can drag and drop like that. Okay, that's interesting.
Now the tool path is generated with the flattened mill, and you'll notice that the normals are derived from the surface, and then it's using the between two curves. So it flows.
Might have to let it go let at least go halfway through, I guess, and then we can get an angle to look at it. Yeah. So you can. So is that just so when I see the tool path going under the gray, is that just a video card artifact?
Yeah, it's just basically fighting for display. So I can say show in hidden areas, and it'll display that for us here. It's just basically trying to, they're right on top of one another. So that's what it means. So.
Oh, okay.
Now I made the display.
So it's literally having to unwind itself right now?
Yeah, it's doing an unwind in certain areas because you're putting a primary axis limit of 0 to 360. So
and it just happens to want to be in between the whole time.
Right. So if you take a look here, you'll see the angles that are being computed. So the angles are actually computed right in here for you. And you can go ahead and take a look. Every unwind is marked in the toolpath. So you will see that happening. So when it sees an unwind, it automatically retracts to a safe clearance so the head can tilt.
Okay. Does the software know like in our machine, if you viewed it, let me see how I could explain this. In positive X, the C-axis 0 is to the left of the Z-axis in the X positive. So in other words, from the top view, as it begins to rotate counterclockwise, positive direction in the C-axis, the 0 is in line with the X positive. So does the software already know that, or is that something I have to tell it, or? So in other words, 0 degrees for C could be anywhere on the Z-axis, right, relative to the machine world coordinate system.
Yeah, C0.
So how does it know where to unwind based on the world coordinate system?
Well, so what we do is all the toolpaths are computed based off your X, Y, Z0, C0, B0. So you probably would be, touching off at one of these points and establishing your origin. So the C and B angles are computed based off your 0, 0 initial position that you set.
Okay. So what you're saying is C0 is aligned with the x-axis or the c-axis?
C is parallel to the z-axis, right? And your A is parallel to the y-axis. So when C and A are 0, which means it will be like a normal 3-axis setup.
Mm-hmm. Mm-hmm. But when C rotates, I don't know if I'm explaining myself well. Here, go to the top view, Uday, and let's just look at the origin really quick. I can show you. Okay, so see the red arrow? Okay, imagine I'm looking down the top of the machine. That's where C0 is, and then it goes counterclockwise positive 360. Okay.
That's correct. That's how we define the machine tool right now. Mm-hmm.
And that's how you define. So when it posts out, it's going to post as though it knows where the physical C0 is then.
Yes.
Okay. Because the machine tool maker could have made that at anywhere he wanted, right?
Mm-hmm.
Okay. All right. Okay. I just want to be clear. Okay. I understand now. Thank you.
Yeah, so this is one of the simultaneous 5-axis methods. And now if I post this out, you will see that instead of C and B, it'll be C and A for your machine. So that the B is swapped out with an A axis. And you can see the compensation on G48.1, which basically you're on. So you don't need to do the gauge length compensation in VisualCAM, and you can basically, have the controller handle this.
Yeah, those numbers actually represent the tool point in the post right there.
Yep.
Right. Okay.
So it basically stays within your rotary axis limits in this case. That's why it's creating those unwind. Now, if I go back in here and set my machine tool to limit to no limit, for example, and I go back and regenerate it, you won't see any of those unwinds.
I know. I wish my machine would do that.
So on a lot of machines, the Z-axis wouldn't have really a limit. Only the limits would be on your A-axis because it's limited by -2 plus 110 or 120 or however.
Yeah. Our machine's actually the opposite. Our C is limited, but our A is unlimited.
So are we getting A and C swapped out here incorrectly here? Because,
no, because ours is a dual head spindle. So it has to be able to do that. Yeah, it literally will spin circles if you want it to. But the C is 0 to 360. I mean, technically -2 plus 362, right? But
yeah.
So I'm stuck with rewinds, unfortunately.
Yeah, here you can see it goes from a positive to a negative +3.7 to -1.7. The C. Since I changed it to no limit.
Oh, okay. Yeah.
And then I had to regenerate. So. Simultaneous 5-axis is about selecting your drive surface, gouge check surface. The drive surface is what computes the tool axis normal. So in a lot of applications, users tend to draw additional surfaces to keep the tool normal to and use these as gouge check rather than using them as drive surface because you might be having a lot of variations going on, but you want to draw a surface that's more, keeping it more uniform too. Or you can do like even as an indexed operation in some of these areas. So if you just want to do these as an indexed operation, you can do that as well. So you can do a
when you say well, you're a little above my learning curve there. When you say index surface, as a check surface,
index would be basically tilting it to an angle, and then program it